Okay, let's say now we have a question to say now express z is equals to 2 minus j3 into a polar form. So basically z is given in a rectangular form, we must convert it to a polar form. So the first thing that we do, remember, a polar form has this format to say now z is equals to r theta. So the first thing that we must do, we must find the resultant. So if we find the resultant, remember this is A and this is B. So when we find the resultant, our resultant squared is equals to what? It will be the real part squared plus the imaginary part squared. Okay? Then when you simplify there, put the square root, you put the square root, and then our r is equals to the square root of 13. Okay. So after we find the value of r, then we must find the value of theta. So to find the value of theta, we can use tangent of theta. So remember, tangent of theta is actually opposite over adjacent. Okay. So remember, on our arc diagram, we actually say the imaginary part is on the y-axis and the real part is on the x-axis. So every time on our y-axis we will have the opposite side, and then on the x-axis we will have what? The adjacent side. So we know now our opposite side is going to be what? It's going to be the imaginary part, which is the coefficient of j. So here we will have -3, and then all over our adjacent side, which is the real part, over 2. I don't know if it makes sense. So every time when you are given a rectangular format like this, you can get your opposite here. You say the opposite is actually the coefficient of j and the adjacent is the real part. Okay, so now for you to find the angle, you will say theta is equals to tangent, second function tangent of -3 over 2. Okay, so one thing you should realize is that when you put a tangent of a negative sign inside here, it will give you a negative angle, of which it will be mathematically incorrect. So if ever you have let's say now your tangent, your number inside your tangent is negative. So what you are looking for, you will first look for the reference angle. So this will be what you get, the answer that you get here, it will be your reference angle. Let me just say, let me write it here, reference angle. So that reference angle, it will be how much? Let's say second function tangent. But when you write your tangent, you write it as positive. You don't put the sign here. So you say 3 over 2, and then it gives us how much? An angle of 56.31 degrees. Okay, that means our reference angle is how much? Is 56.31 degrees. Okay, so but this is not the angle that we are supposed to put here. We have the value of r, which is this one, but now this is a reference angle because we don't know actually where is our resultant place on what? On our arc diagram. So the first thing, for us to determine the angle, we must do what? We must draw the arc diagram. So let's draw our arc diagram to say now on the x-axis we have real part and on the y-axis we have imaginary part. In form, we can represent our arc diagram to say now the real part is how much? The real part is 2. And then the imaginary part is how much? Is -3. So it's -3. So basically, you can just say, okay, this will be our resultant. So our resultant will be here on the 4th quadrant. So we will be correct to say now our theta, our angle theta is going to be how much? It's going to be negative. You can say our angle theta is going to be negative 56.31 degrees. Or if ever we don't write it as negative, we can say it's negative because you can see here this angle here is an acute angle. So we can just say it's negative 56.31. Or we can write it correctly to say now our angle. Remember, when you represent your angle, it must start here. It must start from here on your left hand side, and then it must go where your resultant is ending. So you can say your angle will be here. So as we can see here, our resultant is on the fourth quadrant, and here on the fourth quadrant you will have what? You will have 360 minus the reference angle. So for you to get the theta, you will say now our theta is equals to how much? It is equals to 360 minus 56.31. And then the angle theta, it will be how much? Let's say 360 minus 56.31, which is equals to 303.69. Okay, so now you can represent what? Let me just erase here. You can represent your complex in a polar form as what? As you say z is equals to, what is the value of r? So the value of r we got square root 13, if you still remember, square root 13. And then the angle can either be what? You can write it as negative 56.31, or you can say now your z is equals to square root 13 at an angle of 303.69 degrees. Okay, please be careful here. So sometimes you might find that or your let me just put it this way. Let's say, for example, your resultant is actually on the second quadrant, né? And then that means you will be having, like, let's say is z equals to negative 2 plus j3, né? So it's basically the same thing, but now the problem is that the angle, it won't be the same. So now they say what? The real part, it will be negative 2. That means your real part is going to be written here, which is going to be negative 2. Then now your imaginary part is going to be 3. And then 3 is going to be what? It's going to be here. It's going to be here. So same thing will apply here. To say now you have what? You have your opposite side as what? As equals to 3, because it's the imaginary part. And then your adjacent side is equals to 2. So your reference angle will always be, it will still be 56.31. But now your resultant, it will be where? It will be in the second quadrant. That means the first option to say now your resultant in terms of a rectangular form is square root of 13 and negative 40. It won't work. It will be incorrect. But now your angle, it will be how much? It will be 180 minus theta, because now your resultant is on what? Is on the second quadrant, and the angle, it will be from real to the resultant. I hope it makes sense.